Required to find the value of angle x from the given figure. Label A, B, C and D. We need to find the radius, r of the circle. Length BC, length BD and length CD before we proceed to solving the required angle x. From triangle ABD. Angle BD, A equals 60 degrees. Let length A be equals to y. Using sine rule, the ratio of y to sine 60 degrees equals to the ratio of line BD to sine 40 degrees. Cross multiply and solve for length of line BD. We call the equation obtained for line BD equation 1. From triangle ABC. Using sine rule, substitute values, cross-multiply and make line BC the subject of the formula. We call the equation formed by line BC equation 2. From triangle ABC. Using sine rule, we can now solve for the length of line CD. Thus, length of line CD equals to the sum of length of line BC and BD. We substitute the values for the length of line BC and BD, respectively, we obtained earlier and simplify in equation CD, which we call equation 3. Let us solve for the radius, r. Join radius to A and B, respectively. This implies that angle AOB equals to 2 times angle ACB. Angle at center is twice that at the circumference of the circle. Since line AC equals to line BC, line OC is an angular bisector of angle ACB. Consider triangle AOB. Using sine rule, we have that the ratio of r to sine 70 degrees equals to the ratio of y to sine 40 degrees. Cross multiply and solve for r, which we call equation 4. Reconstruct the figure. Join line OC equals to radius, r. And let angle COD equals to beta. Consider triangle DOC. Using cosine rule, we have equation form for the square of line OD as shown on the screen. Let us substitute values and simplify. Substitute the values we obtained for length OC and CD in the cosine rule formula for the square of line OD and simplify. We have that the square of line OD equals to the product of 0.55090121149 and the square of y. Find the square root of the equation and we have the length of line OD equals to the product of y and the square root of 0.55090121149, which equal to 0.742227199 times y. We call it equation 5. From the same triangle DOC. Using sine rule, we have that the ratio of r to sine x equals to the ratio of line OD to sine 10 degrees. Cross-multiply and solve for sin x. We obtained equation in sin x as shown on the screen. Substitute the value of equation 4 for r and equation 5 for line O, D, respectively, in sin x equation above and. We have equation in sin x as shown on the screen. Sin x equals 0.2538566653 divided by 0.7422271199. Find the sine inverse of the equation. We have that x equals sine inverse of 0.2538566653 divided by 0.7422271199, which equals to 20 degrees. Therefore, x equals to 20 degrees.